You've been told your thermostat controls the room, but we already know that's not entirely true. You've seen inside a VAV box. But even a perfectly working VAV can't fix the real problem if the heart of this system is failing. Today I'm cracking open the air handler unit, this massive machine that everything else depends on. Stick around because by the end of this video, you'll understand why some buildings feel great and while others are constant money pits. And you'll know exactly what to look for in your next service call. Welcome back to Building Automation Pro. I've troubleshooted hundreds of these systems in offices, hospitals, and schools. In this video, I'm going to show you exactly how the AHU works, the expensive mistakes I see all the time, and the simple fixes that can save thousands of dollars in energy costs. Let's dive in. Here's the simple truth. Your thermostat sends a signal, the VAV box opens or closes. But all that air has to come from somewhere. That somewhere is the AHU. Outside air comes in, mixes with return air, gets cleaned, heated or cooled, then the fan blasts it out to every VAV in the building. Sounds straightforward. But when one small thing goes wrong here, the entire building suffers. I'll show you the exact components and what kills the performance. I once walked into an office building where tenants were freezing on one side and roasting on the other. Turns out the AHU was the culprit. Fixing it took one afternoon and stopped hundreds of complaints. Right at the entrance, you have a mixing section with 3 sets of dampers. You have the outdoor air damper, return air damper, and the exhaust damper. Question for you. How much fresh air do you think a building actually needs? Most people guess wrong. Too much outside air in the winter has huge heating bills. Too little, bad indoor air quality, and a sick building syndrome. The building automation system constantly adjusts these dampers when it works correctly. When it doesn't, that's when problems start. On one job, a stuck outdoor air damper was dumping freezing air straight into the building every night. The actuator failed months earlier, $180 part, months of high energy bills and low temperature alarms. It can be fixed in under an hour. Next up, the filters. Dirty filters are silent killers. They make the fan work harder, raise energy costs, and starve your VAV boxes of air. Watch the differential pressure gauge. When it gets too high, you already have a problem. Now we get to the coils, where the real magic happens. Hot water and chilled water runs through these fins and conditions the air. One dirty coil can cut efficiency in half. I'm going to show you something most videos skip. How to quickly tell if your coils are a problem without tearing everything apart. I'll never forget. I went to a building with an AHU and the cooling coil was so clogged it looked like a black brick. Airflow was terrible, people were uncomfortable, and energy bills were through the roof. 2 hours with a coil cleaner and the supply fan speed dropped dramatically. And the building saved a fortune. The supply fan is the muscle of the whole system. Modern units use variable frequency drives, so the fan speed can go up and slow down as needed based on a static set point. This is critical in VAV systems. When VAV boxes close, the fan must ramp down or you will waste massive energy. I'll show you the duct static pressure sensor that controls everything and what happens when it lies. Here's where building automation shines. The AHU controller is watching temperature, pressure, CO2, filter status, and more, all at once. When everything works together, you get free cooling with economizer mode. Perfect supply air temperature and low energy use. When it doesn't, simultaneously heating and cooling, fans running full speed for no reason, and angry tenants. Later I'll give you my top 3 things to check. First, when someone calls and says the building isn't cooling. Real-world problems I see constantly. Failed damper actuators, dirty coils killing airflow, bad static pressure sensors causing fan to be hunting back and forth, drain pan overflows creating mold nightmares. The AHU is really the heart. Understand this piece and you'll finally see how the thermostat, VAV, and central system all work together. Now I want to hear from you. What's the strangest AHU problem you've ever seen on a job? Drop in the comments. I read every single one. If this video helped you understand the system better, smash that like button, subscribe, and hit the bell so you don't miss the next one.